the data and we want to hold on to it. In other words, if we didn't hold on to the data we were interested in, it would get washed away in all of the bits and we would not have it to utilize in our programs. So what we need is a way to set up a storage location in memory so that we can have a variable that we can access later. So it's a named location in memory. And specifically, it's in our RAM, in random access memory. What we're going to do is we are going to ask the computer to reserve a space in memory so we can store a value in it, and then all we need to do if we want to access that variable at a later point is we need to go ahead and ask for it by name. Usually we name variables logically based upon their use. A couple other things. So let's go. Let's declare a variable. What this basically says is, hey computer, I need some space in memory. So I'm going to go ahead and I'm going to declare a variable called, I guess we'll call it tax. And I'm going to actually not just put the word variable there, but I need to, whenever you declare a variable, Java is what's called a strongly typed programming language. And what you need to do in Java when you declare a variable is you need to go ahead and you need to tell Java what type of information is going to be stored in there. And basically, what is the data type that's going to be stored into that location. And in my case, I'm going to put double here because I'm going to store tax. So it says set me up a location in memory called tax, and be aware that the only information that is going to be stored there will be of type double. Now I've declared the storage location and it is available in memory. Now I can go ahead and I can initialize the variable. And what I can do is I can set the tax, and this is Pennsylvania, so we'll go for 0.06 tax. Notice I'm ending each line with a semicolon. Important. I mean, at this point, we've seen it a bunch of times, but it ends each simple statement. So what's happening on line 9 actually goes ahead and sets up the storage location, and then what happens on line 12, it puts the initial value into that location. What's in the location if I don't initialize the variable? Nothing. Junk. Well, actually in Java it'll put some false value in there, but if this was C or C++, you'd have whatever value was in that location in memory previously. So it's kind of like if you've ever rented a car and they don't clean it out, you get all the junk that the person who rented it before you got, and that's just not fun. In Java, it'll actually clean things out for you. But just one point. You can actually do both these steps at the same time. And what I'm going to do is make another variable that holds an int, and I'll just call it high score, and I'm going to set it to 1,000. So notice I can both declare and initialize a variable at one time. The only time you need to put the data type for the variable is the first time you declare the variable. So it says, hey, give me a storage location. It's only going to hold doubles, and I'm going to refer to it in the future as tax. So here's what's kind of cool. We want to go ahead and we want to print this out. All I need to do now is tell the computer where the data is stored, what storage location it's stored in. I'm going to go ahead and ask for the storage location named tax, and it's going to go ahead and it should print out 0.06. And we'll actually do this twice, and we'll have this one print out high score. And then what we'll do now is we'll go ahead and compile, and we'll print it. And notice that we get the values that we had stored in those locations just by asking for them by name. So we set up a named location in memory. We tell the computer what type of data is going to get stored there, and then what we do is we go ahead and we ask for that by name. We can also change these. So let's say, we'll make this a little bigger. The tax gets modified, so we can reset tax to be 0.10, which I hope doesn't happen, but let's say the tax gets changed. Notice that our programs get executed top to bottom, left to right, just like we would expect from reading. And you'll notice that in this case I initially set the tax variable to 0.06. Down here I'm going to go ahead and I'm going to change it to 0.10. Whenever you change a variable's value, it overwrites the old variable. This is not going to add 0.10 to 0.06. It's actually just going to overwrite. So whatever was there initially gets kicked out. So I'm going to recompile, and I'm going to run it. And now you'll notice this time the value that gets printed is 0.1, not 0.6. Why? Because after I initialized the variable, I came down here on line 18 and I changed the value. Kind of cool. Kind of interesting. So let's see what else we can do with variables. First of all, notice our output is kind of boring. It's just 0.1 and 1,000. So how can we modify our output? We can use concatenation. So we could put, sales tax in PA is, and now we can use the plus operator. And remember, in this instance, the plus operator means to concatenate. It's going to take the string on the left and add the string on the right. And here we'll put, current high score is. And now what I've done is I've effectively labeled my information. So I'm going to compile this. I'm going to run it and get everything in one window. And now notice how the string sales tax and PA was glued onto the value stored in the location called tax. And same thing happened to the high score. So this process of concatenation allows us to, we'll put that here, concatenate two values for readability. In other words, what this just does is it lets the end user realize that they know what the data is. It's never good to just get numbers printed out to the screen. We want to think a little bit about the user experience as we're writing these programs. All right, so a couple other things we can do. Not only can we change a variable, I'm going to comment this out. Let's say we want to take the current value in tax and we want to add something to it. So instead of changing it to 10, let's just say we want to add 0.2% to it. We can actually change values. On the right-hand side, we can actually put mathematical operations. And in this case, what I'm going to do is add a value to, let's just go back and say add 0.02 to the value stored in tax and store the new value back into tax. Here's what's interesting. On your computer, just like in regular math, mathematical operators have an order of operation. In this case, everything on the right-hand side of the equal sign happens first. Okay, and this is actually not the equal sign, it's what I would call the assignment operator. Okay, because in this case what we're doing is saying take everything on the right, perform any math if necessary, and then assign it to the storage location on the left. So in this case I'm going to take 0.10, I'm going to add I'm going to take 0.06 because I commented out line 18, add 0.02 to it. It's going to take 0.06 plus 0.02. It's going to get the value 0.08, and then when it's done, it's going to kick the old value out of tax and store 0.08 in that. So what we say here is right side happens first. So items to the right of the assignment operator happen first. Then assignment occurs. So let's go ahead, compile it, and run it. And so you'll notice that I get on line 26 that sales tax and PA is 0.08%. It's not, it's 0.06, but why did this happen? Well, up top here, we set tax equal to 0.06. We read the value 0.06 from the variable, added 0.02 to it. The computer temporarily gets the value 0.08 and stores the variable 0.08 or the value of 0.08 back into the tax variable. And then the next time we access the tax variable, it prints out the most current value, which is 0.08. So this idea of adding and working with values in variables is pretty important. We can do the same thing with high score. Let's take high score and let's just take the current value of high score and divide by 10. Why am I doing this, by the way? You can think of this as really reusing variables, just kind of like you would in an environmentally friendly setting. You don't want to waste natural resources. You also don't want to waste computing resources. So in this case, it's really helpful that I can reuse an existing value. So that's some basic components of working with variables, some basic components of concatenation and printing out values.